Welcome everyone. For this lab, we're going to be looking at two different properties. We're going to first be exploring how temperature can affect how molecules move. So you're going to be seeing evidence that changing the temperature changes how fast molecules are moving. And then the second part of the lab is going to be looking at the properties of solids and liquids and determining whether or not Oobleck, which I have over here, Oobleck is a solid or a liquid. But we're going to start by looking at the different, how changing temperature changes the speed at which molecules are moving. And to test this, we have some boiling water, and then we have a water bottle that's just covered with a balloon, which creates an airtight container. No air can get in or out of this container, and you can see that the balloon is deflated. But when I put the balloon in, or when I put that water bottle with the balloon in the hot water, you'll see something interesting starts to happen. The balloon begins to inflate. Now, as I mentioned, this is an airtight container, so there's no way that more air is getting inside of this to inflate the balloon. So the question becomes, why is the balloon inflating when we put it in this boiling water? Now, there's always a couple hypotheses that kids come up with, and I always really like the one in particular that says that there's a convection current happening. So we've already learned this year about how when we have a heat source at the bottom, which this is, the air at the bottom will become less dense because it's warmer and it will rise up. So students always predict that maybe this is just a convection current and there's not any difference other than that the air is rising. But if I flip this water bottle over, if it was a convection current and the air in here is now just less dense, by flipping it over, all of the air should rush out of the balloon towards the top of this bottle and the balloon should deflate, but it does not. So instead, a more accurate look at what's actually happening is as the air inside the bottle heats up, the gas molecules are moving faster and faster. And when they move faster, they have more energy, and any collisions they have more force. So the slow-moving air at room temperature is not pushing very hard against the balloon, but the really fast-moving air inside the bottle is pushing very hard against the balloon, and it causes it to stretch and inflate. And we can do the same process in reverse by putting this water bottle in a freezer and slowing the air down as much as possible. And that's gonna take a couple minutes, so I'm gonna pause the video here. But while it's paused, make a hypothesis. What's gonna happen to the balloon after I put this water bottle in a freezer? So here you can see the bottle now that it has been removed from the freezer, and the bottle's very cold. So the air inside this bottle is moving much slower and therefore has less energy than the air just moving around in this room. So the air in the room hits the balloon with more force than the air in the bottle, and you can see the balloon is being pushed into the bottle. And if I line this up more carefully, you can actually see that the whole balloon tends to want to suck straight down into the bottle. So the air from the outside is pushing the balloon down into this bottle because the air has less energy in this bottle than the air does outside of the bottle. And then once again, this is quite easily reversed by simply heating up the air inside the bottle. The air will become more energetic, and you can see the balloon is starting to be pushed back out again. So if we look at this, the main idea is that the hotter something gets, the faster those molecules are moving, and therefore those molecules have more energy. Thanks for watching. Next up will be the Oobleck portion of the lab. Let's take a look at the Oobleck portion of this lab now. And for the Oobleck portion, you're trying to identify ways that Oobleck behaves like a liquid and ways that Oobleck behaves more like a solid. Well, let's start with some liquid. When this is sitting in its container, Oobleck will take the shape of its container. It does not have a fixed shape. So objects that don't have a fixed shape, that is a property of being a liquid. You can also see that oobleck is capable of flowing or pouring. As I move the bowl around, it will flow around within the bowl. And then maybe a third option as a liquid is I can stir it, right? I can put this pin in here and it'll sink down. You can see it's not very deep, but it'll sink down and I can stir the oobleck. So those are some principles that would act as a liquid. Let's take a look at some ways that oobleck behaves like a solid now. So we already demonstrated that you can stir oobleck and that it flows. But if you notice, if I pull up quickly, it lifts the entire container. So if I pull up quickly, it turns to a solid and the entire container moves up with it. And when you move slow, it sinks in. But if I hit the oobleck with any force, you cannot push the marker through. It turns into a solid. And if you look more closely, you can almost see for an instant where that oobleck really does behave exactly like a solid, to the point that you can even pick some up and just move it around as a solid. So oobleck can behave both as a solid and a liquid. Your task is going to be to decide which one it actually is. Is oobleck a solid or is oobleck a liquid?